Assalamualaikum and hello everyone. Today my group and I will present to you guys about our assignment project, and we are from SMG3013 Class A Group 3. And you guess what? Our group already chosen the topic for our assignment project is main gate of the UPSI Museum. Okay, now we have to go to the introduction part, which we have the location of the museum gate, the function or usage of the museum gate, and then we have the actual size of the museum gate. It's so impressed, right? So now let's go. Okay, for this assignment, we already know my group and I have already chosen a unique architectural structure located at UPSI, which are the main gate of the UPSI Museum. This gate stands out because of its distinctive design, detailed pattern, and meaningful history background. According to historical record, it was designed by Castellan, a renowned architect from the era of the Federated Malay States. This gate is more than just an entrance. It is a symbol of heritage and traditional art. Made from high-quality hardwood, it reflects both aesthetic beauty and strong durability. It also features carvings that are rarely found in modern architecture today. Visually, the gate is decorated with geometric shapes like isosceles triangle, trapezoid, cuboid, rectangle, and much more, and hence its overall artistic look. The use of bright color, especially shade like thick wood, adds to its beauty, making it one of the most iconic landmarks on the UPSI campus. The UPSI Museum Gate, located at the main entrance of the museum area, right to the next of TENGKU Library. The museum itself reflects the history and development of UPSI through 4 key periods, which are SITC, MPSI, IPSI, and the last one is UPSI. Each of these phases adds to the museum classic and traditional design. The gate plays a significant role in showcasing the long-standing educational heritage of the university. Its carving not only catch attention, but it also serves as inspiration for our project. The main purpose of this gate to serve as the primary entrance and exit of the visitors and students of the UPSI Museum. However, beyond its practical function, it also acts as a meaningful historical structure, representing the university architectural and cultural legacy. Today, it is viewed as a symbolic landmark, because of encouraging both students and visitors to appreciate its detailed craftsmanship and historical value. It has also become an educational attraction, highlighting the university-rich background. The size of the museum UPSI gate is large and visually impressive. You know why? It built to suit its role as the main entrance. It is made entirely of solid hardwood, offering both strength and elegance. The gate measures approximately 94 inches of wide and 150 inches high, and it is spacious enough for around 20 people to pass through at the same time when they entrance the door. Its carving include rectangular shape measuring 16 inches and mirrored pentagon design measuring 8 inches, making it just not secure but also a creative architectural features.
In this section, we have selected 5 different geometrical shapes that are commonly used in mathematics and design. The shapes we choose are hexagon, cuboid, trapezoid, triangle, rectangle. Each shape has its own unique features and formulas, especially when calculating area and perimeter. Now, let's move on to the concept behind each shape, where we explore their definitions and properties in more detail. For this section, we will focus on the rectangle and the triangle. So the first one is rectangle. A rectangle is a type of parallelogram that has 4 right angles or 90 degrees at each corner. It is a 2-dimensional, or we call it 2D, shape that lies flat on a plane. To calculate the perimeter of the rectangle, we use this formula. Perimeter equal to side plus side plus side plus side. 13 cm plus 61 cm plus 13 cm, and the last one is plus 61 cm, and we got the answer 148 cm. Therefore, the perimeter of our rectangle is 148 cm. Now, we calculate the area of a rectangle using the formula. Area equal to base multiplied with height. 13 multiplied with 61, so the area of this rectangle is 793 square centimeters. Next, we have the triangle, specifically an isosceles triangle. This means the triangle has 2 sides of equal length, which give it a symmetrical appearance. The triangle in our example, as such measuring 20 cm, 21 cm for the base and another 20 cm. To find the perimeter, we add all sides together, which is the perimeter 20 cm plus 21 cm plus 20 cm, and we got the answer 61 cm. Then we calculate the area using the formula. Area equal to 1/2 multiply with base multiply with height. So 1/2 multiply with 21 cm multiply with 11.5 cm, and we got the answer 120.75 cm square. So the area of this isosceles triangle is 120.75 square centimeters.
The hexagon is a closed two-dimensional polygon with 6 sides. Hexagon has 6 vertices and 6 angles. This geometrical shape is irregular hexagon, which is the length of the side and measure of the angle do not have the same measurement. This hexagon is twice of the trapezoid. So the perimeter of the hexagon is summation of 6 sides, which is the first side is 11.5 cm plus 10 cm plus 10 cm plus 11.5 cm plus 10 cm plus 10 cm equal to 63 cm. Then the area of the hexagon is given by twice area of the trapezoid. So the area of trapezoid is given by 1/2 of multiplication of altitude of line, which is L, and the summation of base of line, which is B1 and B2. The altitude of line L is 8.5 cm and the base of line B1 is 11.5 cm and B2 is 20 cm. So the unit measurement of area of hexagon is cm square. So the formula of the area equal to 2 times H times B1 plus B2. So substitute the value, so we get 267.75 cm square. The trapezoid is a quadrilateral with exactly 2 parallel sides. This trapezoid is right trapezoid. Then the perimeter of the trapezoid is summation of each side. So trapezoid has 4 sides. The formula of perimeter of the trapezoid is sum of 4 sides of the trapezoid. So 13 cm plus 44 cm plus 38 cm plus 15 cm. So equal to 110 cm. Then the area of the trapezoid is given by 1/2 of multiplication of altitude of line, which is L, and the summation of base of line E1 and B2. The altitude of line L is 30 cm and the base of the line B1 is 44 cm and B2 is 38 cm. The unit measurement of area of trapezoid is cm square. So area, so substitute the value into the formula, so we get 530 cm square. Then the geometrical concept that has in the structure is cuboid. So cuboid is a 3-dimension, which is 3D shape with 6 rectangular face, 12 edges and 8 vertices. It's a type of prism, specifically a rectangular prism. So the perimeter of a cuboid is summation of each length. Since cuboid has 3 sets of 4 edges with equal length, where L is length, B is breadth, and H is height of the cuboid. Cuboid has 12 edges. So the perimeter is equal to 4 times L plus H plus B. So 4 multiplied by 112 cm plus 206 cm plus 4 cm equals to 1288 cm. Then the area of a cuboid is given by multiplication of length and height of the cuboid. The length of the cuboid is 112 cm and the height of the cuboid is 206 cm. The unit measurement of area of cuboid is centimeter square. So substitute the value into the area formula. So the area formula of cuboid is 23,072 cm square. So next is the volume. The volume of cuboid is given by multiplication of length, breadth and height of the cuboid. The length of the cuboid, which is L, is 112 cm. The height of the cuboid, which is H, is 206 cm, and the breadth of the cuboid, which is B, is 4 cm. The unit measurement of area of the cuboid is cm cube. So substitute the value into the formula. So the volume of the cuboid is 92,288 centimeters cube.
Next, transformation in motif and pattern. There are three types of transformation, which is let or translation, that every point of the original figure is associated with a second point by locating it through a movement of a fixed length and direction. Second is reflection, which is each pair of corresponding point will lie on the opposite side of the line of reflection at the same distance. Last, rotation occur when every point of the given figure leads to a point its image by rotation about a given point through a prescribed angle measure. Next, transformation in motif for hexagon. First, translation. The figure show hexagon ABCDEF is laid down to form hexagon MNOPQR. Rotation also occur for hexagon pattern. The figure show hexagon ABCDEF has been rotated 180 clockwise at point A and form image which is hexagon MNOPQR. Next, reflection of the hexagon occur when hexagon ABCDEF is reflect over x-axis to form hexagon MNOPQR. Each point mapped to a new point whose distance to the x-axis is the same as the distance to the x-axis from the original point. Next, we move to transformation in motif for rectangle. Transformation occur for rectangle is translation. The figure show rectangle ABCD is slided to right to form rectangle EFGH. Next, rotation. The figure show rectangle ABCD has been rotated 180 degrees clockwise at point A and the image is rectangle EFGH. After that, reflection. The figure show rectangle ABCD is reflect over y-axis to form rectangle EFGH. Each point mapped to a new point whose distance to the y-axis is the same as the distance to the y-axis from the original point.
Okay, so now we'll continue to transformation in motif for isosceles triangle. There's a two transformation in motif for isosceles triangle. The first one is rotation. As you can see in the figure, it shows two isosceles triangle that has been labeled. The first one is isosceles triangle ABC and the second one is isosceles triangle DEF. Isosceles triangle DEF is an image of the isosceles triangle ABC after rotation. Isosceles triangle ABC has been rotated 180 degrees clockwise at a point A. For the second transformation is reflection. As you can see in the figure shows, there are two isosceles triangle that has been labeled. The first one is isosceles triangle ABC and the second one is isosceles triangle DEF. Isosceles triangle ABC is a reflect over y-axis, horizontal reflection, to form isosceles triangle DEF. Each point mapped to a new point whose distance to the y-axis is the same as the distance to the y-axis from the original point. Okay, now we'll continue to trapezoid. There's a two transformation in motif for trapezoid. The first one is rotation. In the figure shows, there are two trapezoid that has been labeled. The first one is trapezoid ABCD and the second one is trapezoid EFGH. As you can see in the figure, trapezoid EFGH is an image of trapezoid ABCD after rotation. Trapezoid ABCD has been rotated for 180 degrees clockwise at the origin. For the second transformation in motif is reflection. In the figure shows, there are two trapezoid that has been labeled. The first one is trapezoid ABCD and the second one is trapezoid EFGH. Trapezoid ABCD is a reflect over negative x-axis equal to y-axis slanted reflection to form trapezoid EFGH. Each point mapped to a new point whose distance to the negative x-axis equal to y-axis is the same as the distance to the negative x-axis equal to y-axis from the original point. Okay, now we continue to transformation in patterns. There's only one transformation in pattern, which is reflection. In the figure shows, there are reflection over y-axis, horizontal reflection. Each point mapped to a new point whose distance to the y-axis is equal to the distance to the y-axis from the original point. The summary for our case study is UPSI Museum Gateway explore the architectural design of the campus heritage building, analyzing geometry shape like triangles, trapezoid, hexagons, and cuboids. It also explores geometric transformation in carvings and decoration, highlighting the integration of maths in traditional building design. So the conclusion is, this assignment demonstrates how geometry can be used to analyze and appreciate real-world building, like UPSI Museum Gateway, enhancing student understanding of mathematical precision and visual designs, and demonstrating its fundamental role in aesthetic and structural building design. Thank you, that's all from us, bye-bye!